Well, thank you for having me. This has been a real different kind of project for me because we have focused a lot more on not just cultivars, although that has been a focus of mine over the years, but to look at those with respect to Fusarium wilt. And so there's a number of people that are involved in this project, and I'd like to make sure I acknowledge them from the get-go. I'm kind of leading this aspect of this project, but Tony Keinath and I are working extremely close together because we're, as you'll see, we have complementary different tests that we have at our individual sites. One will be shown today in Charleston, and the other, of course, in North Carolina in Clayton. And Lina is our plant pathologist, extension plant pathologist and researcher, and works with watermelon, and as actually head of this project in which this is being funded from. And so we are working on with her nursery there, where she has Fusarium wilt presence. And so I want to make sure I acknowledge her for sure, and also talk a little bit at the end of what kind of recommendations she would have when she makes a presentation with how to manage Fusarium wilt, at least the best that we know how. So without further ado, we'll go ahead and talk about the objectives. And the key objective here was to determine the cultivar response, basically the percentage of plant incidence. And we looked at that each week for the Fusarium wilt symptoms in the field with the pathogen Fusarium oxysporum niveum, both in Clayton, North Carolina, and in Charleston, South Carolina. And then once we figured that out, we then went back in and see how that might have corresponded to yield, the amount of percentage wilt incidence. And so those were really the main things that we looked at. Now, if you look at this, let's look at the panel on the left, and let's talk about some of the different treatments, and then we'll look at the right here in a moment on the percentage of incidence. We transplanted this fairly early in the year, April 27th, and the reason and I'll make mention of this, and I'll probably repeat this again at the end, you tend to get more favorable conditions for the pathogen to be able to grow earlier in the season when it's cooler. And so the idea was to get more Fusarium coming in and competing with the growth of the plant. And so if you plant it much later, you tend to not see as much of perhaps that infection. And that's been shown with a number of research projects. In fact, we'll have some of that being perhaps just mentioned in the speaker that follows me, who did a lot of the work. The data I'm going to show is at 10 weeks after planting. I'll do that for both of the studies so that they're the same. We grew on plastic mulch. We used drip irrigation. The thing that is kind of neat about this, and probably why there's a lot of interest, is it's a triploid trial. We're not looking at Fusarium wilt resistance for diploids necessarily, although that can be important if we use pollinizers that you're trying to get particular yields from, or to keep them alive so that you have flowers that are present. So that can be a consideration, and may be something in addition to what was not outlined in this particular grant to look at that further. This is very driven, this project, by the seed companies. And you see a listing of those companies here on your left. And what you see is a couple of different cultivars provided by BASF or Nunums, and a couple by Cicada, some from Syngenta and Seminis. And then you also have one that was provided, not the cultivar necessarily of the triploid, but the different rootstock called Carolina Strongback, which we put in as a control that's supposed to have resistance to Fusarium wilt, which has more than one race or variant. Kind of like COVID, we got all these races going on. Well, we got different races going on with the Fusarium wilt, and we have at least race 1 and 2, and then there's debate whether we have a virulent race of race 2 or a race 3. And then finally, you see that USVL, we did not replicate that. That is a seeded variety that came out of this grant that was originally funded several years ago. And that supposedly might have some Fusarium wilt resistance. It could perhaps be used as breeding material, but it is a seeded cultivar and it has a rind pattern that people really aren't particularly growing and selling here in the US. So if we look over at the right-hand panel, what you'll notice is those bars traverse across the panel pretty far. This is the amount of incidence the plants had, number of plants or percentage of incidence. And you can see that the top listing, the grafted fascination, we didn't find any of the plants that got any of the Fusarium wilt. None of them. We see fascination did seem to have a little bit less, at least had it numerically less, around 75, 78%, somewhere in that range. And then the rest of these had 80 or 100% of the plants that showed Fusarium wilt symptoms on the plants. And so all those blue lines, statistically anyway, were the same. And the reality-wise, if you saw that kind of amount of incidence in your field, you'd be in trouble. What we want to see is something pretty close, if we can get it, or be at 0%. And that was put in there for a control reason to see. So, you know, we've done a lot of work with grafted materials, and we looked at it in conditions where they were in fields where they were not challenged by Fusarium wilt, and that they were supposed to have wonderful characteristics of really growing fast, and you know, maybe you don't need as many plants, and some people don't use as many plants, but our results generally showed that if you use less populations, you got less yields. So we didn't see a lot of differences in that way, but we do see it in this case where they are challenged, these plants, by the amount of Fusarium, by those that with Fusarium wilt in a field. So just to give you an idea, this is the field setup. Those flags there that you see, the orange ones are 4 weeks. We would mark each plant and go through and say that has Fusarium wilt. Or if you see red flags, which you see a few in there, those are ones that had it at 3 weeks. And so if you look at the plots a little bit closer, you can see some of the plants starting to wilt in that plot. The first one's in pretty bad shape. The fourth plant's not looking too good. If we zoom in and we look at a plant, one of the things we looked at to detect it is, are there some leaves that are showing wilts? We always would look at this in the morning, so as the sun wouldn't be contributed if it was super hot later in the day and there was wilting. But this is a very classic where you see one of the vines starting to go down and the other vine is healthy. It's a vascular disease. It plugs up the xylem where water moves. And so here's another very classic symptom where one vine looks good and the rest of them are all starting to go bad. And then if it's early enough, like this was at 3 weeks, it looks like this plant is basically had its day. It's dead, or at least it looks for the most part dead. We saw some of those, which was interesting, that look like that. And a sprout might eventually emerge, but it would never grow out much past the width of the plastic. And these were very severe symptoms. In addition, where you'd look on the vine and you'd see this brown like droplet or ooze, and that was emblematic of this particular disease. So let me show you some other data over time, and you see this big spaghetti mass of colors, and they're all pretty consistent what was going on over time as far as the percentage incidence of Fusarium wilt. And the color lines are matched with the various entry or the various cultivar that we used. Notice that at the very bottom, there's the yellow line, and that's the grafted fascination with Carolina stromback. That's a wild watermelon type that has that resistance and grows out pretty normally like any watermelon. Notice the gray line, which tended to be a little lower, fascination. That we didn't get statistical differences, but it was tending to be lower than the others, but still very, very, very high incidence across all of the different cultivars. So as we get to the end, before we're getting close to harvesting these watermelons, this is how the field sort of looked. And you can see some of the vines are starting to go down in general, but you see a lot of flags in there. And each colored flag would signify different times when we started to see the incidence of Fusarium wilt. And you see a lot of flags out there, a lot of flags. So really about everything really had it pretty bad, except the grafted materials. And so here's Triax 313, one of the very first varieties that was grown, or cultivars. Here's when seedless watermelons were introduced in the 80s and 90s. Here's Shoreline, it's a Seminus entry, and all of those had pretty much the Fusarium wilt in it. And you can see there's melons in there, but a lot of those melons are the pollinizer. We used SP7, which has resistance to Fusarium wilt 1, race 1 and race 2 for those two different races. So you don't see much of anything in there, and there wasn't much of anything as far as a very nice looking watermelon that could harvest. The other thing is, because the vines were so hurt, you see a lot of scalding by the sun. So that's another issue. You look at fascination, and still not grapevine color, but you can see some of those darker green or striped melons in there, which did yield some fruit that were reasonable quality. And so we would get about 1 fruit every 2 plants. That's still not very good, but at least it's a little bit better than the others. And then this is fascination when it was grafted to Carolina Strongback, and you see excellent vine cover, and you can still see some of the watermelons that are of high quality, what you're looking for in fascination, peeking through the vines, and some you can't see because of the vine color. But if you go through and look at this slide, you probably can see at least a half a dozen or so fruit that are in there that you can see, and then there's a whole bunch you cannot see. And this would happen to be the USDA line, which did not show any Fusarium wilt, but then it has that odd different color and it's seeded. So just a quick mention of that, part of the QCAP grant that we originally obtained in earlier years. So let's look at the yields and look at that panel. And if we look at that, you can see that the main harvest occurred on July 2nd. We had a second harvest, but there wasn't a lot of fruit in there. To remind you, we had 10 plants per plot, and we just categorized what the yields were on a per plot basis. We had 4 replications, which means we had 4 different places in the field to make sure that if there was a hot spot with Fusarium, hopefully it didn't get penalized that variety was only in that hot spot. It was randomly placed throughout the field. But anything that was 9 pounds or more, that's the number of fruit we got on a per plot basis. We suspected when we originally had done this that we only had Fusarium race 1 from talking with Lina's team. The field was inoculated, not this year, but the year before, or 2021, but the year before that. We had several cultivars that we supposedly had Fusarium wilt race 1 resistance, and yet they were dying. So that bothered me because, why are all these things dying if there's only Fusarium race 1 in there? And so I put in there, thank you to Syngenta, especially, and BASF, who I still need to get more of a report from them, but we sent off a number of samples to determine what the races were. That's what the differentials are talking about there, to determine where certain types of cultivars or lines might show the wilt occurring when they test them in the greenhouse or in the lab, and others do not. And basically, they were able to determine what we had as far as the different races in the Clayton plots in North Carolina. And what we found out was Syngenta had told us that we had race 1. We also had race 2, but we not only had race 2, but we had a virulent race 2, or they called it, or sometimes it's called race 3. So if we look at the yields, it's a fairly obvious type of thing. Grafted fascination out yielded everything. We averaged almost 20 fruit per plot, which means we averaged about 2 fruit per plant, which is a good yield. Fascination, we were somewhere around 5 or 6 fruit, marketable fruit or size fruit per plot. A little bit more with El Capitan and Sierra Madre in the middle, and then everything else was like 2 to 3 fruit or less in a whole plot that were 9 pounds or more. So it really, we really didn't get that much yield on any of those because they were so hit by that Fusarium wilt. Now let me shift to the South Carolina. That was done by Tony Keinath, and he was really, what he got was what we were hoping to see more in North Carolina, but we didn't. And he saw some pretty different results. And he has gone into that field, and he knew he had races 1 and 2. There was a mixture of those races throughout the field. He does not apparently have this more virulent race or race 3 up to virulent race 2. And what he found, the blue bars tell you the percentage of incidence of the disease, and you can see that the fascination the grafted had 0. The embassy, though, did pretty well in his plots. He had less than 20%. Powerhouse, which is a new variety from Syngenta, did a bit better, 7197, which has been a favorite for many years, maybe less grown today than it used to be 5, 6, 7 years ago. It did well. And then fascination did well as well. And it looked better, again, in our plots a bit better. The lighter blue bars all statistically were the same. So Triax 313, even though it was a little higher numerically, had similar amounts of incidence of Fusarium wilt on a per plant on the plants. Then you get to the darker blue bars, and you see Sierra Nevada, El Capitan, Joyride, and those all had higher amounts of Fusarium incidence than those others I just mentioned, which were a bit lower. And the highest amount of incidence occurred in the Seminis variety Shoreline, which had close to 70% incidence at basically 10 weeks after transplant. And then if you look at the area of disease, another kind of measure, progress curve, which is the orange bars, they're very similar in how those results came out compared to the amount of percentage of Fusarium wilt incidence as indicated by the blue bars. If we look at the weight, and they did it a little bit differently, we did numbers per plot. He did basically the weight, I think, per plot. And you can see the fascination that were grafted had the highest weight. And then Embassy, Powerhouse, 7197, and Fascination had the next highest yields. And then Triax 313, Sierra Nevada, El Capitan, and Joyride with the next highest yields, and the lowest yields were obtained with Shoreline. And what's interesting is he did what's called a Pearson correlation. In other words, how well does the marketable weight correspond to that disease incidence? And it correlates extremely well. We had 92% of it correlating. That's at R value 0.92 or 92%. And you can see that the fascination grafted was the highest, and the as far as yields, but had low incidence or none. And then Shoreline had the highest incidence on the right of the graph with that little dot of Fusarium wilt, but also the lowest yield. So it was a pretty straight, nice line. And that orange line that's kind of there is a 25% or so mark of incidence. And you can kind of see that those all had higher yields when they were at least 25% or less. So let me summarize this. The cultivar response did vary due to the field we were in, or the environment, basically what was present in that field, and also perhaps the growing conditions. Only treatment in North Carolina that even reduced Fusarium wilt incidence was the grafted fascination on the Carolina strongback rootstock, as no incidence was observed with Fusarium wilt. All the other cultivars were 75 to 80 to 100% incidence at 10 weeks after transplant. And we had some help with Syngenta to determine that races 1, 2, and 3, or the virulent race of 2 were present. The yield response reflected Fusarium wilt treatment incidents again. And we got about 2 marketable fruit produced from each grafted plant, whereas we got 1 marketable fruit from every 2 plants with fascination that was not grafted, and less than 4 fruits from 10 plants with all the other cultivars. And if we look at South Carolina and summarize that, there was much more separation in cultivar response. As in North Carolina, the Fusarium wilt incidents observed with the fascination cultivar grafted to Carolina strongback rootstock, there was none. But MSC Powerhouse 7197 and Fascination had less Fusarium wilt incidents than the other cultivars, and they ranged between 10 and 25% 10 weeks after transplant. Most susceptible cultivars, and the most susceptible cultivar in South Carolina, it was high in North Carolina as well, was 68% Fusarium wilt incidence. The field used for South Carolina, Tony Keinath had looked at that, and they have races 1 and 2, as I mentioned earlier. And the yield response, as I also indicated earlier, was correlated extremely well, 92% with Fusarium treatment incidents. So let me just transition a little bit to talk about recommendations. These are from Lina, who's our plant pathologist and extension vegetable specialist, working particularly with sweet potatoes and cucurbits and a few other crops, but those in particular. And, you know, she shows a real nice photo, and I just wanted to show this, that one of the telltale symptoms beyond just looking at the vine wilting, like I showed earlier in some of those pictures, if you were to cut the stem open, you would see a browning of the vascular system. That's a good telltale sign that you've got Fusarium wilt, especially in conjunction with some of the different vines or terminals going down, and some seeming to be healthy. And if it's really a bad situation, you could lose the whole plant, and often do. Dispersal and survival. This Fusarium can enter into fields from contaminated seed. And I think that is going on. I don't know how you actually, the way you prevent it is not to get contaminated seed, but it's really critical what the seed companies, I think, are doing to make sure that they're not spreading this disease necessarily, because that's a concern. I think that's probably where we may have gotten that in the field we used this year, is from contaminated seed. The transplants, you don't want to have that in your transplants. You don't want to move your farm equipment around, you know, because if you get soil and have that disease in the soil, you can move it from place to place, and all of a sudden that accumulates and you get it worse and worse, and you got a real problem. And it will survive in fields for a long, long time there's a structure called a cometospore. It's a resting spore with a thicker cell wall on it, and those things will last. They can be in the field for 10 years. So once you've got it, you got a serious problem. So the management that she suggests, that Lina suggests, again, is to use pathogen-free seed and transplants. So you need to have, you know, good materials that are clean from seed companies. You need to try to use resistant cultivars. We do see some differences in South Carolina depending on what the races are and maybe their proportions, that some are better than others. We didn't see so much of that in what we planted at all in North Carolina. You can apply effective fungicides at planting. There's not a lot of choice there, but you can use Proline as a drench or a drip at planting, as this was found in some of her research to reduce Fusarium wilt, which resulted in increased yields. Plant and raised beds with plastic mulch, they're more infected when cool, but they'll also show the symptoms a lot more when you get a lot more fruit set, and it pulls a lot on the vine, and they can't support it because of the vascular system where water moves being cut off because of this disease. She suggests the 5-year rotation. That still may not even get it. I've heard as much as 10 years at least to get it. And I'm sure she says 5 to get basically as long as you can wait. There may be certain cover crops that can be used. She really hasn't mentioned those that would be used. Maybe there's some suggestions from those that are listening here that could offer some suggestions. And then grafting, as you saw in that, you saw very, very well in this study, is definitely a solution one can use. There are different resources for disease management in general, and there's an extension plant pathology portal, and that's listed there, the link. And so you can get information not only about Fusarium wilt, but also other diseases and how to manage them and what to look for. And then there's also our Southeastern Vegetable Crop Handbook, which gives information on plant variety recommendations, pesticide selections, post-harvest handling, and other management practices. So these are available. The new one, the 2022, I didn't put that one up, but the 2022 is up. Hard copies are being distributed. Some of them have been already and will continue to be hopefully this month, but there are also this digital copy that is available online. And finally, I think I need to acknowledge those folks that have supported this work. This is supported by a fairly large grant by the U.S. Department of Agriculture. The award numbers listed there. I might mention that we have a website called QCAP. The link is listed there. That's what the logo kind of looks like for QCAP, and it doesn't necessarily have this present. Well, I guess this may be posted up there by our web manager, Mary Lorscheider, after this. I know she wanted to put that up there. But there's good information that is on there about what the project's about, some of the different things that are going on, even much more upstream with some of the molecular basis, but also some very practical information when it comes to management of cucurbit diseases. Special thanks need to be given to these companies because it is driven by what they're willing to provide us as the newest materials. And they're all working on trying to improve, because they know they need to, resistance to the race 2 Fusarium at least, because they really don't have a lot to show for the race 2 resistance at this point. But Nunham's or BASF, who owns them, Cicada, Seminis, and Syngenta for giving us their cultivars that were maybe the latest, and also Trihistel, who provided us with those wonderful transplants that were grafted, and we appreciate that. And then finally, where we do the work on the research station at Central Crops Research Station in Clayton, I want to thank Charles Barrow, who oversaw that as the Hort Crops manager, and all the staff that were involved. And of course, I didn't list them there, but we had a whole host of different people that work with my different project that I'm overseeing to be able to do this work.